Hey, OChemsters, this is Mrs. Vandelay bringing you OChemster video. We're still in chapter 7.9. We're continuing our discussion on reactions of alcohols. We learned on the last video that alcohols can undergo dehydration process, which would be an E1 or an E2, to produce an alkene water and then, of course, your leaving group, probably bromide. What else can alcohols do? They can react with halogen halides to give alkyl halides. Okay, what the heck does that mean? Well, let's find out. Well, here is my alcohol, and my hydrogen halide is exactly what it says, a hydrogen either with a chlorine, bromine, or iodine. And why would not HF count? Because what do you recognize of these three acids? These are three of the strong acids. HF is a strong weak acid, but still a weak acid. It doesn't 100% ionize like these guys do. And what are we going to make? Well, let's pause for a second. Do you remember this? This is not on your page, but it was on prior. Remember, if you can make water, you will make water. All right, that's huge. Okay, and you're going to see this over and over again. It's a nice, principle to keep in the back of your head as you go through these things. All right. So where does this water come from? It comes from right here, doesn't it? All right, there's your water. So that's why we need a strong acid so that will 100% ionize to have a tremendous source of H plus ions. And so then what do I get? I get an alkyl halide. So whatever carbon group is here is this carbon group here with a chlorine in this case, or it could be a bromine or it could be an iodine. And guess what? Water, because what? If you can make water, you will make water. All right, so what kind of a reaction is this? This is not an elimination. Why do I know that? There's no double bonds. I don't have any heat. All right, so if it's not elimination, it's probably substitution. How come I know it's not addition? Addition has only one product. Here we have two products. You might be jotting some of this down, by the way. And two products we said in chapter 6 was indicative of a substitution reaction. That's a good word, indicative. All right. So anyway, it says because the halide ions are good nucleophiles, I spelled substitution wrong. The substitution products are obtained instead of dehydration. All right, there's no heat, whatnot, okay? So then what do you think it depends on? Is this going to be SN1 or SN2? Well, it depends on what? Once again, you've heard this before, is this carbon that's attached to the oxygen, primary, secondary, tertiary. All right, so let's check out your tertiary alcohols. These react the fastest. Basically, you just need to shake it to get that, activation energy going, and boom, there it goes. Okay, so what does this do? All right, so let's take a tertiary alcohol. There's one. Oops, wrong one. This one, there we go. That's the one I wanted. There's my tertiary alcohol. And now I'm going to take my HCl. I don't know why I could have used HBr or HI if I wanted. And what's going to happen? Well, folks, if you can make water, you will make water. And so what do I get? I get this over here. All right, is my alkyl halide, and don't forget, I make some water, okay? So what's going on now? It says steps 1 and 2 are just like the reactions for dehydration. Remember what those were? Well, I need to take my alcohol, and remember, this is a strong acid. So what does it say? What do I say it does? It 100% ionizes to make an H plus ion. So what do you think is going to happen when I do that? So I can draw this. This H is going to be attracted to the highly electronegative oxygen, and I'm going to make this right here. Okay, so now I have this protonated alcohol group, if you will. The oxygen is now a partial positive, or the whole part it has that positive ion, I should say, excuse me. So what do you think is going to happen now? All right, well, see here, this, all right, the water is going to come off, okay, just water water is going to come off. And so why would just water come off? Why wouldn't the H whatever plus come off? And the reason being is water is so stable, all right? It doesn't need the plus, all right? It's very, very stable. And what do you know about what's left over? I have a carbocation. Okay, so my carbocation, because it's tertiary, is more stable. All right, so this is a more stable arrangement than this is. So what's going to happen? So the water is going to come off. All right, let's show you that. So the water is going to come off. All right, but this plus is going to go to the carbocation. A tertiary carbocation is quite stable. So now what happens? I'm going to take my carbocation. And don't forget, if I had an H plus here, what else is lurking around? There's plenty of chlorides floating around. And what's going to happen? This negative and this positive are going to go, hey, baby, let's bond, all right? So I guess I can do something like that. And now what? They're going to bond, and voila, there is my alkyl halide, okay? So what about SN2? Really the same thing, the final result anyway. So here is this, and here is that. And why would I put a bracket around the OH and the H? Guess what? If you can make water, you will make water, all right? But when you have a primary, you're going to need a little extra help. Okay, remember how easily we said that tertiary alcohols make the alkyl halide? All you have to do is shake it at room temperature and go, go, go. Primary doesn't work as well, all right? They are slower, they have to be heated. You think, oh, is that going to be elimination? You might get some with a mixture of hydrochloric acid and a catalyst. So you have to do more with this to make it go. So then what? Well, again, it's a substitution. So the water is going to be made, and then the alkyl halide is going to be made. So let's look at the mechanism and how this happens. It seems to be a common theme here. The step one, the alcohol is protonated by the acid. Remember, I'm using a strong acid. That's why HF is not included. And I am protonating my alcohol, okay? So now what? All right, the chloride ion is going to displace the water. So this is your SN2. Do you remember we did talk about SN2? So the chloride, I threw the hydrogens in here just to kind of show you something. So the chloride has to like sneak around the back. Remember this? All right, so momentarily what's going to happen? All right, that carbon here has 5 bonds. Holy cow, can't do that. All right, so then what? In a sense, the water is now my leaving group. When it leaves, this plus becomes part of the carbon for the carbocation, and the chloride is attracted, you know, is already taken care of. Like it's already been attracted to it. And you make your alkyl halide. So it's all one swoop, all right? So this comes in, freaks out the poor carbon with approaching 5 bonds. The water leaves, the plus goes on the carbon, the chlorine takes its place, and boom, it happens immediately, okay? Well, guess what? Secondary alcohols can react by either SN1 or SN2. Oh, that sounds familiar, doesn't it? All right, problem number 1 explains why T-butyl alcohol reacts at equal rates with either hydrochloric acid or HBr or HI. It makes no difference which strong acid you use. So think about it. Go back and look at what T-butyl, that's your tertiary alcohol. So pause this, think about this, write something down, and come back, and when you're done, we'll talk about it. All right, welcome back. What is the first step in a tertiary SN1 reaction? The leaving group leaves. All right, so the H2O leaves. It doesn't make any difference which acid you're using. Water is going to leave first, all right, and then the halide hops on. So it's at equal rate because they're all strong acids. It really doesn't make any difference which ones. This is what I wrote. HCl, HBr, and HI are all strong acids. T-butyl alcohol is tertiary that dehydrates by the, oh, it's not. Silly Mrs. Vandal. All right, I fixed that. All right, so TBO alcohol is tertiary that dehydrates. That still works. Dehydration means take away water. We're still taking away the water. But this case is by the SN1 mechanism, not the E1. So sorry about that. So by the SN1 mechanism. And the first step in SN1 is protonating the alcohol, also in the E1 too. All right, so each of these strong acids will work the same. Okay, sorry about that. I'm glad I fixed it. Let's go on to the next problem. So what's going to happen here? Oh, you're supposed to, oops, write the equations for the following alcohols, each with concentrated HBr. Why don't you take a few minutes out and do this, and when you're done, come back. We'll see you in a minute. All right, welcome back. Hopefully you got this done. So again, it's just a simple swap. We have the protonated H plus, so here's where my water is going to come off, and then the bromine's going to take its place. A simple substitution. All right. Did I have to worry about R and S here? No, this is tertiary. What about the next one? All right, so here, this is a carbon right here, right? So this is a primary. So once again, I don't have to worry about R or S. The OH went away with the H, and then the bromine took its place. And that is the end of chapter 7.9. Hope this helped. Don't wait to be great. We'll see you next time. Bye-bye.